Good morning, everybody. So this is just a continuation of the video where I started working on the specimen multiple choice for physics, right? As I indicated in the previous video, for those of you who don't know me, my name is Terry David, and I am the author of the study guides for CAPE Physics 1 and Unit 2. Alright, now in the previous video, we completed questions 1 to 30. So I'm going to be continuing from 31. Okay, so this is question 31. So in this question, we have a ray of light passes from paraffin into air. So this is paraffin here, and this is air, and they gave us the angle of incidence as being 28 degrees. And if the refractive index of paraffin is 1.44, what is the value of sin x? Now, they're telling us that the refractive index of paraffin is 1.44. So n from A to paraffin is equal to sin I over sin R, right? We need to start off with this. Now, A to paraffin we know is 1.44, and sin I, right, is really this angle here, right? Because of how when we state refractive index, we're talking from A to whatever material it is. So in this case, it's going to be sin x divided by sin R, which is sin 28. Right? So if we cross multiply here, then we're going to get sin x is equal to 1.44 by sine 28 degrees, right? And in which case that gives us the answer as B. So number 31, the answer is B, right? So you need to be careful with this. Some students will make a mistake with this and get an incorrect answer, right? Just remember, when they quote refractive index for you, they are actually quoting from A to that material. Now, number 32, we have some ray diagrams, right? And these are for a diverging lens, and they want to know which one is correct, right? Now, when a ray is parallel to the principal axis, it bends this direction, so therefore this diagram is correct. For this particular one, I'm not sure what they're showing here, but that's not one of the diagrams that we know. In the case of the third one now, if a ray passes through the center, it's undeviated. So therefore 3 is correct. So therefore the answer is 1 and 3. Right? Number 33, we have the refractive index of light traveling from air to glass, and they're asking us which of the following is true, right? Right, so what they're asking us for is n air to glass, right? And we know n air to glass will be the speed of light in air, so it could be the speed of light in air over the speed of light in the glass, right? So this one is not correct. Refractive index could also be, so n air to glass can also be lambda A over lambda glass. So the wavelength in air over the wavelength in glass. So therefore 2 is correct. And the frequency of light in air over the frequency, so this is incorrect, right? The formulas that relate to refractive index has to do with speed, it has to do with wavelength, it also has to do with sin I over sin R. right? So the only answer there is actually E. Now let's look at number 34. Alright, so they want to know from the diagram, you want to get a real image. So you want a real image, and you're producing this using a convergent lens, and when the object is located at. Okay, so you all need to remember the ray diagrams for the different positions, right? If I put an object between the center of the lens and the focal point, let's say between at this point here, what is going to happen is that I'm going to get an image that is erect, imaginary, and magnified, right? That's for if it's less than f. So, okay, so this should have been, so D is wrong because D will give us a virtual image, right? In that particular scenario, we're talking about something like a magnifying glass. At f only, the fact that they use the word only is not true, and at 2f only, that is not true. So if we place an object anywhere between f and infinity, I'm going to get an image, sorry, that is real, right? And therefore that answer has to be C, right? Let's go to 35. So 35, when Young's double slit experiment is conducted, it is expected to show. So Young's double slit experiment shows that light can show interference, right? That's the whole purpose of it. Light can show interference, right? And if it can show interference, it means it's a weave, right? So let's see what they want to know. It is expected that light can bend. Okay. A series of dots on a screen. Light travels in a straight line, and interference patterns on the screen. So basically the answer is D. We're looking for the best answer here. So the answer is D. Number 36. We have pitch and loudness, right? So pitch depends on something you need to know about sound waves. So pitch depends on frequency. And so that's pitch. And loudness, what do we do? Depends on the amplitude of the wave. Alright, so pitch depends on frequency, and amplitude, loudness depends on amplitude. So the answer is B. Number 37. One sec, right guys, just hold on for a sec. Yeah, sorry about that. Somebody was calling. Alright, so in this particular question, a lady faces a mirror which is 5 meters away from her. She views the image of the V's, which is 0.5 meters in front of her. How far from her is the image in the V's? So how far from her is the image in the V's? Image of the V's. So she is 5 meters from the mirror, and the plant is 0.5 meters from her, which means that the distance of the vase from the mirror is going to be 5 minus 0.5, which will give me 4.5 meters, right? Which means that the image of the vase is actually 4.5 meters behind, right? So this is where the image is going to be. And the question wants to know how far from her is the image of the vase. So the image from the vase will be 4.5. Yeah, so like I was saying, alright, so we want to know the image, the distance of the image of the vase from her. So therefore that should be 5 meters plus 4.5 meters, which is equal to 9.5 meters, right? So in this case, the answer will be D. All right. Let's look at this one here. So we have a transmitter. It emits radio waves at a frequency of 750. So F is equal to 750 kilohertz. If the velocity of the EM wave, so we know V in this case is 3 by 10 to the 8 meters per second. And the question wants to know what is the wavelength. So we need to use V equal F lambda. So lambda is equal to V over F, right, which is 3 by 10 to the 8 divided by my frequency, which is 750, but it's kilohertz, so it's 750 by 10 cube, right? So this is going to be, let's see what we get for that, 3 by 10 to the 8 divided by 750 10 cube. We're going to get 400 meters as my wavelength, right? So for this one, the answer is going to be C. Let's do number 39. Alright, so for this one here now, we have a circuit diagram. It's a parallel circuit, and they give us what is R1. R1 is 6 ohms, R2 is 4 ohms, and they want to know what is the current in R1 if the current in R2 is 1.8. So the current in R2 here is 1.8, and they want to know what this current is here. Now, basically we are using our circuit diagram laws here. So if I know the current flowing through R2, I can know what the voltage across, I can know this voltage here, right? Because I know the current flowing through the resistor and I know what the resistor is. So I'm just going to use V equal IR, which is equal to 1.8 multiplied by 4, right? So 1.8 multiplied by 4, and that will give me 7.2 volts, right? Now what that tells me is that because R2 is in parallel with R1, the voltage across this is also 7.2 volts. And if I want to work out this current here, this I, then all I'm going to use is I is equal to V over R, which is the same 7.2 volts that you got, divided by the resistance here, which is 6, So that's 7.2 divided by 6, and I'm going to get 1.2 amps. All right, so this is A for number 39. All right. Oh, I just realized, okay, so there are some people in the class right now. Good morning. So, one sec. All right, so let me go on to number 40. So your transformer is connected to a 100 volt supply, and the output measured is found to be 10 volt 10 amp. What is the primary current? So you all need to remember what a transformer looks like. So you have a transformer. Transformer looks like this. Transformer typically has a primary coil, and it also has a secondary coil. On the transformer, they're saying it's connected to a 100 volt supply. So therefore my voltage in my primary is 100 volts. All right, and the output is measured. So my VS, my secondary voltage, is 10 volts, and my secondary current is equal to 0.5 amps. All right, now they want to know what is the primary current, so they want to know IP. So there are some transformer equations you need to know. That is, number of turns in your primary over the number of turns in the secondary is equal to my voltage in my primary over the voltage in my secondary, right? But we also know that if we assume that a transformer is ideal, my power input, which is IP VP, is equal to IS VS, right? So I'm going to make use of the second formula here, which is IP, we don't know, multiplied by my voltage in my primary, which is 100, which is equal to IS, which is 0.5, multiplied by 10. So therefore IP is equal to 0.5 multiplied by 10 divided by 100, right? So IP is equal to 0.5 by 10 divided by 100, and that gives me 0.05 amps, right? So therefore my current in my primary should be B. Now let's look at number 41. So number 41, they've given us a truth table, right, for some logic gate, and we want to know what that truth table represents, right? So there are some truth tables you need to remember and some diagrams. The easiest one is what we call a NOT gate, right? So if we have a NOT gate is also called an inverter, and basically whatever the input is, it's going to invert to give us the output. So if we have a 0, we're going to get a 1, and if we have a 1, we're going to get a 0. Now ideally, all you really need to learn is 3 of them, right? And you can figure out any others. So we have another gate called an AND gate. This is A, this is B, and this is C, and this is called an AND gate. And if we draw the truth table for this, we're going to get, so we have 0, 0, 0, 1, 1, 0, and 1, 1, right? Essentially, I'm counting in binary there. Now, for the AND gate, what you need to remember is that the output is only a 1 when you have a 1 and a 1. So you're going to put a 1 here, and everything else is going to be 0. So that's an AND gate. Then we also have another gate called an OR gate. We have 2 inputs. So we have A, B, C, and this is called an OR gate. And we have A, B, and C, and my input's going to be 0, 0, 0, 1, 1, 0, 1, 1. Now, in the case of an OR gate, you're going to get a 1 with a 1 or anything else. So therefore, I'm going to get a 1 here, 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 but I'm going to get a 0 here. So all you really need to do is to learn off these three, and you can figure out for the NAND and for the NOR. Now let's look at the truth table here. You realize that the truth table is high for everything except 1, 1, right? Now, the only gate that kind of looks like that is, we're looking at the AND here. Now the AND is only high or 1 when we have a 1 and a 1, right? But the thing is, in this table they give us here, it's a 0. So therefore, this table is actually showing me a NAND gate, right? That is what it is showing me. So the answer for number 41 is D, right? This is a NAND gate. Now, let's look at this next one here now. Instead of a transformer, NS is greater than NP, so my number of turns in my secondary is greater than my number of turns in my primary, the transformer is. Now, anytime the number of turns in your primary and secondary are different, it is either a step up or a step down transformer, right? So therefore, a smoothing transformer is wrong, an alternating transformer is wrong. So we're looking at step up or step down, right? Now, if we have more turns on my secondary, that's what it's saying, you have more turns on my secondary, and I have less turns on my primary, right? Now remember, in a transformer, my primary is here, and my secondary is here, right? So my secondary, so this is secondary, and this is primary, right? And they're saying that the number in the secondary is greater, which means I am stepping up the voltage. And the formula that I'm using to make that assumption is this. Number of turns in primary over number of turns in secondary is equal to voltage in primary over the voltage in my secondary, right? So therefore, that is, in this particular case, it's a step-up transformer, right? So the answer is this. All right. Hey Tyrese, morning. I didn't realize you were here. Let's do the next one here. Where am I? Alright, so this is number 43. Which of the following quantities is constant in a parallel circuit? Right? Which of the following is constant in a parallel circuit? So they're talking about a circuit that looks like this. So visualize a parallel circuit. Alright, and the parallel circuit is like this. So they said which of the following is constant. What we do know about a parallel circuit is that the current flowing through my components in the parallel circuit may not be the same, right? But what we do know is that the voltage, so let's say the EMF across this here, my cell, right? Let's say that's V, and we take our next reading here, and this works out. So let's call that reading V1, and we connect the next voltmeter here, and this reading is V2, and this reading at the top here is V. We know that V1 is equal to V2, which is also equal to V. So what we are saying is that for a parallel circuit, my voltage is constant, right? That's what they're trying to get at. I mean, the wording is not the best, but that's what they're trying to get at. Number 44. A magnetic field can be used to deflect the path of. So they're trying to see which of the following is affected by a magnetic field. Now, in order to be affected by a magnetic field, you must have a charge. So beta particles, well, except beta rays is really particles. So beta particles, they do have a charge. They have a negative charge. So that will be deflected. Gamma rays, they have no charge. So this has no charge. So we know that that is unaffected by a magnetic field. X-rays have no charge, and light rays have no charge as well, right? So they want to know which one can be used to deflect the part of. So the only one that has a charge is a beta particle, right? So the answer is E. This next one is 45. Right? This is one of those questions that they bring all the time. Which of the following scientists discovered the relationship equal mc squared? And the scientist we're talking about here is Albert Einstein. Every child in primary school knows this. Equal mc squared. It's Albert Einstein. Number 46. For any two consecutive elements in the periodic table, the first element has one less. So this is number 46, right? For two consecutive elements in the period. So in the periodic table, the elements are arranged based on atomic number, right? Atomic number, or what we call my proton number, right? So therefore, if we have an element here, and let's say the atomic number is 6, and we have an element that is right next to it, the atomic number or the proton number is going to be 7. So they want to know for any two consecutive elements in the periodic table, the first element has one less, has to be proton, right? So it has one less proton. Number 47. For a radioactive substance with a half-life, particular half-life, as time increases, the radioactive substance vanishes, increases, decreases, remains constant, right? So that is 47. So for a radioactive substance, the decay curve looks something like this. So this is time, and let's say this is number of atoms. It can also be, so this could be number of undecayed atoms, right? It can also be activity, right? Those are the two things we can plot against time. Activity, right? So, and basically the graph looks like this, right? It has an exponential curve, right? So this is my initial activity. After one half-life, which is the time taken to decrease by half my initial value, this here is going to be my half-life, right? So these are the things that you need to know. When we decrease by half of that, right, which will now be n0 over 4, a quarter, then we have another half-life here, right? So what is happening is that the radioactive substance, it decreases. It never vanishes because it will never reach to 0, right? It doesn't increase and it doesn't remain constant. There are some things that you need to know about this graph, right? I saw somebody said once online that when you plot a graph like this, the graph actually looks something like this. It's never a smooth curve, right? If in the exam you see they ask you, why is it not a smooth curve? Please do not tell them because of experimental errors. That is incorrect. That is wrong, right? The reason why it's not a smooth curve is because radioactive decay is a random process, right? So this is what you need to say. It's a random process. That is why the graph is not a smooth curve. And also, the radioactive decay, we say that it's a spontaneous and random process, right? It is random because if we were looking at the particles that make up a sample, we cannot predict which particle is going to decay. That's why it's random, right? The next thing is that it's a spontaneous process that takes place inside the nucleus. Now, what that means is that if I heat it, I'm not going to affect how it decays. If I apply pressure, it's not going to affect how it decays, right? So it's a spontaneous process, and it occurs because of nuclear instability. All right. So in this one here now, number 48. What did Geiger-Massen experiment establish as being present in the atom? Right? You all need to be able to draw a diagram and explain what is the Geiger-Massen experiment. Right? So basically we have a circular table, we have a gold foil, we have an alpha source, right? So you all need to know this experiment, how to explain it, how to describe it. We have something like this, right? So it's also called the gold leaf experiment. I'm sorry, let's call it the Geiger-Massen experiment. So what is happening here is that we have an alpha source, and the alpha source is being projected on a thin sheet of gold foil. So this is gold foil, and we have a microscope slide here coated with zinc sulfide. So it's coated with zinc sulfide. Every time an alpha particle hits the zinc sulfide, you get a flash of light. So that's how you detect the alpha particles, right? That flash of light is called a scintillation. And in this experiment, most of the alpha particles went straight through the gold foil, some were deflected, and some returned back to the source. Those are the three different observations from the experiment, right? Most of it passed straight through, some were deflected, and a few went back to the source. Now, what that tells us is that most of the nucleus, or most of the atom, is made up of empty space, meaning that the nucleus is very small. Because we have deflection, it means that the nucleus has to be the same charge as an alpha particle, therefore it's positively charged, right? And the fact that some particles went back to the source means that the nucleus has to be extremely, extremely small, right? So what this is doing here is basically confirming the nucleus of the atom, right? So the answer is B for this one. Number 49. They said the atomic number and mass number of an atom, right? So we have some element. The mass number is 120 and the atomic number is 50, right? That's what they're telling us. That means that there are 120 protons. That is wrong. Can't be 120 protons, right? Yeah, so it can't be 120 protons. 120 neutrons, that's not true either. It has, all right, so from this here, we know we have 50 electrons, right? That's this number here. We also have 50 protons, all right? So these two numbers are always the same if what we are representing has no charge, right? So the number of electrons equal the number of protons. And to get the number of neutrons, we're going to have to say 120 minus 50, right? Which is equal to 70. So it has 70 neutrons. All right? So for number 49, the answer has to be D, 50 protons and 70 neutrons. All right? Number 50 now. So they said on Sunday, the corrected count rate of a radioactive source was 240. So it's 240 counts per second. Exactly 2 days later, the count rate had fallen to 120. So it went to 120. After exactly 4 more days, that's on Saturday, the count rate per second was, all right, so they're telling us if we go from 240 to 120, that took us exactly 2 days, right? Now, if you go from 240 to 120, it means you have decreased by half your initial value. So what that tells me is that my half-life is equal to 2 days. That's what that's telling me, right? Now, so on Sunday, the corrected count. So this is Sunday here, right? And what else they're telling us? Right, so exactly 2 days later, the count rate, right, after 4 more days. So if you're going 4 more days, right, it means that you are going through 2 more half-lives. So 1, and after that half-life, you're going to get half of that, which is 60. And then you're going to go next 2 days. So this is 2 days. This is 2 days. And this will give me 30, right? So in which case, the answer has to be 30 counts per second, right? Now, please note that all the calculations at the CSEC level on radioactive decay is extremely straightforward, right? You see what I'm drawing here with the arrows? That's all you need to know. Only when you go to Form 6, then we have a formula to actually work this out, right? Number 51. They're telling us when you have a polythene rod and it's rubbed with cloth, what happens? So a polythene rod, when you rub it with a piece of cloth, right, the rod becomes negatively charged, right? If the rod becomes negatively charged, it means that the cloth is going to become positively charged. Now, in that rubbing process, because this got a negative charge, it means that electrons are moving from the cloth to the rod, right? So the polythene rod becomes negatively charged. So the answer could be C or D. And it becomes negatively charged by gaining electrons, right? So the answer has to be D. Number 55. I'm sorry, number 52. So the role of a transformer in electrical circuit is to, so a transformer, what we do, it will basically change a voltage. We can either step up a voltage or step down a voltage. So the answer has to be E, alter the voltage, right? It doesn't change the frequency. It doesn't convert alternating current to DC current, because what does that is a semiconductor diode, right? That's what does that. Number 53. Which of the following materials are conductors, right? So this could typically be a question in the chemistry paper as well. So wood is not a conductor. Gold is a conductor because it's a metal. And graphite, even though it's not a metal, it can conduct electricity. So it is 2 and 3 for this one. All right. Let's look at this one here now. So we have Fleming's left-hand rule. So we use Fleming's left-hand rule when we want to determine force, right? So this is applied to the motor effect, right? So some students confuse the two rules. You have the left-hand rule and the right-hand rule. The left-hand rule is used to determine the direction of the force, whereas the right-hand rule is used to determine the direction of the current, right? When we are producing electricity or producing a current by electromagnetic induction. So if we're looking at the left-hand rule, in the left-hand rule, your thumb is force, 2 is field, and your second finger is what we call my current, right? So basically we're looking to see 1, 2, and 3 has to be force, field, and current. So it's force, field, and current. So the answer is D. Number 55. A student is required to measure the resistance of a resistor. So we need to know that resistance is equal to V over I. So we need to measure the voltage across the resistor, and we need to measure the current flowing through the resistor, right? So there are two symbols that we use for resistor, which is this, or we can have this, right? Most of the exam questions actually use this one. First time I'm really seeing this as a symbol here. But any one is acceptable. So I need to have something looking like this. I need to measure the current. So I need an ammeter in series with the resistor. And I need a voltmeter that is measuring the voltage across the resistor, right? So which diagram gives me that? So the only one that seems to be giving me that is C. right? Give me 1 sec. All right. So next one, number 56. So we have a circuit diagram here. Which lamps will be lit when the switch is closed? All right, so we're closing the circuit here, right? And we're going to see what happens. So R is connected across the power supply. So therefore R is going to light for sure. And what you've effectively done here by closing the switch, you shorted out this. So therefore Q is not going to light at all. But T is going to light. So the answer should be R and T, which is this one. All right. Now 57 now. We have a coil and it's wrapped around, shows a coil carrying a current wrapped around a wooden cylinder, which shows the magnetic field directions at X, Y, and Z. Right? Now, what you need to do for this particular one here, we need to use our right-hand grip rule to figure out what is happening to the field, right? So if I use my right-hand grip rule, what is going to happen is that, let's see, right-hand grip rule. Right, so if you're using a right-hand grip rule, it means that this side here is going to be my north and this side here is going to be my south, right? So my field is going to look like this on both sides, right? Now if it's a north pole here, it means that the field is going to do this. This is how the direction is going to look, right? And also what is going to happen, you're going to have a field around here, all right? And how that field is going to go, it's going to go like this, all right? So basically you're drawing the field lines for a magnet essentially, or a solenoid, and the ones that are going to give us that will be B, right? Look at the directions here. So X, this is X here, X is going to correspond to this direction, Z is going to correspond to this direction, and at Y you're going to get this, right? Number 58. Which of the following is not true when a magnet is moved to a coil, relative to a coil? The greater the number of turns on the coil, the smaller the induced EMF. Now let's say which is not true. When it comes to these multiple choice questions, you need to read them carefully because they could be trying to trick you, basically. Right? So they say which of the following is not true. It's not true. So the greater the number of turns in the coil, the smaller the induced EMF. That's not true. The greater the number of turns, the greater the EMF. Right? The faster the magnet moves relative to the coil, the greater the induced EMF. This is true. This is true. The stronger the magnetic field, the greater the induced EMF. That is also true. So the answer has to be one only, which is this. Number 59, we have what we have here. In the electric field, all right, so we're talking about electric fields, and they want us to, what charges should go in A and B. So you all need to know if you have a positive charge, the field looks like this, right? And the field is away, right? So this is for a positive charge. For a negative charge, it's going to move towards, right? So in this particular case here, A has to be a positive charge and B has to be a negative charge. Now, never mistake in the diagram, because you have fields moving towards here, towards here, towards here, and then they made a mistake here, right? This is really supposed to be inwards, all right? So it's a positive and a negative charge. So my answer is D. And the last question, they give us a decay equation and they want to know the value of A and B. What you all need to remember is that when I add up my mass numbers on the left side, it should equal to when I add up my mass numbers on the right hand side. So therefore 220 is equal to A plus 4. So therefore A is 220 minus 4. So A is equal to 216. And then if we look at the atomic numbers now, we can say that 86 is equal to B plus 2. So B is 86 minus 2. So B is 84. So it's 216 and 84. So the answer is B. Alright, so we've just completed the specimen paper from the syllabus. Right, in the public domain I cannot do any actual multiple choice exams, but what I can do is the specimen papers, right, because this is in the syllabus, it's in the public domain, right. So I'll be doing the specimen paper for chemistry as well, so look out for that. So this is only from questions 31 to 60. I did the previous video with 1 to number 30. All right, so I hope this was helpful to some of you all. So take it easy and look out for the one for chemistry. Alright guys, later.